Hey, hi Ganesh. Thank you for coming for this interview. We will start this interview shortly. So let me give my intro. So I'm working with a company and I'm near to have 4 years of experience and I'm currently working as a data engineer 3. Will you please give little intro about your experience and then will you please make me explain one of your project which you have currently worked on or one of your favorite project that should be related to data engineering, and then we can start our interview.
Yeah, sure. Glad to connect with you, Ankur. I'm Ganesh. So basically, all my experiences in data side, whether you call it data engineering or data warehousing, or back from the days when I started my career 15 years back, it's just called a BI, right? BI analyst, the BI engineer, and data warehousing came into picture, and then now we call it as data engineering. But so I started with SAP. SAP is one of the biggest ERP. It has a very complex OLTP structure with a lot of normalization. I started looking into the data warehousing, meaning when I was placed in Accenture as a fresh college grad, I was put into a team which works on a product called BW, which is basically business warehouse. It's an SAP all-in-one product. It includes the ETL mechanism, data modeling, transformation, and orchestration. BI, security, everything is an all-in-one package tool. Great product, specifically, very closely in line with the SAP product. So think of it this way. It's your data warehousing system, but very, very tightly integrated with SAP. So I worked on this product, for long, very, very long. Almost like 10 years. And last 5 years, I switched my gears into the outside of SAP world, again on the data side, looking at AWS Cloud, Snowflake, basically on the other end of the spectrum. There are great things with SAP. Like I said, it's an all-in-one product, very closely integrated with the SAP ERP. Very, very big companies in the manufacturing world use SAP. They struggle to get their data warehousing into a other ecosystem. But overall, what is happening in the SAP world is SAP is not very innovative. The new products, the cloud and all is beating. So that's where I switched my gears into Snowflake and AWS. Right now, what I'm doing is I set up the data governance and the data strategy for our enterprise. I work for a petrochemical. We have a global presence. So we grew by acquisitions. My company acquired a lot of other companies. So we have a lot of data systems. So data is siloed in multiple systems. So what I'm doing is basically I lead a team of 4 people, a couple in offshore, couple here on site. So we are looking at some of the modern data architectures. I looked at Snowflake, Databricks, Redshift, Synapse, Google BigQuery, but based on our requirement, we have a clear mandate to choose either AWS or Azure because of other reasons. Because we are not only just looking at the data warehousing or data engineering for operational analytics, but also we are looking at, like I said, for a manufacturing company, we have a lot of sensor data coming in from our plants.
Okay, and is it you are doing analysis on the batch or you are also dealing with a streaming type of system?
Yeah. So mostly batch environment because our use cases are running around, providing data to the data scientists. So we have
Mm-hmm.
a big data science team, and they want to build some prediction models.
Mm-hmm.
Um, so we use a streaming service, but
Mm-hmm.
mostly that is so data. This streaming, this IoT data is sitting in a data historian.
Mm-hmm.
It's something called as AspenTech IP21 𝗦ci𝗶. So these are time series databases running
Mm-hmm.
actually in the on-premise.
Mm-hmm.
So typically most of our use cases are batch.
Mm-hmm. Okay, cool.
We also deal with some of the streaming capabilities.
Okay, so you talked about multiple technology like Redshift, then BigQuery and PySpark and multiple Snowflake and other things. So as an architect, how do you decide that I have to use Snowflake or I should use Google BigQuery here? So what is your deciding factor if you are starting your project? How do you design and how do you put framework in the place?
Yeah, no, very good question. I have been in the same problem a few years back. What should I choose, right? If you go um, into the marketing material, everything looks great, right?
Mm-hmm. Mm-hmm.
So this was the criteria I have been using. Like I said, we have a lot of our the big goal. What we are trying to do is to combine the IT data coming in from these SAP, Salesforce, and
Mm-hmm.
also some of the operational data coming in from these plant systems.
Mm-hmm. Okay,
Um,
so let's talk about Salesforce. So when you are getting data from Salesforce, so how you are getting data? Is it through some API or through some batch API? How do you get data from Salesforce to your system?
so basically, we use MuleSoft. So we kind of this is a typical manufacturing company. We are not heavily IT focused, so we usually depend
Mm-hmm.
on tools. So we use the
Mm-hmm.
MuleSoft APIs to pull the data.
Pull the data from Salesforce, is it?
Yeah.
Okay. So have you ever seen that you are actually getting data? So there can be two ways, right? One you can do using paginations or something like that when you are getting data from some API, like hitting multiple API with certain number of records, or you can also do the batch load where you will just ask API just to hit the API, and the
Mhm.
API will just respond in after some times after processing it, and in the you can hit after certain interval like it's in progress or it's completed. So whenever you are taking the data from, let it be any API, MuleSoft or Salesforce and other things. So which one you will prefer? Will you prefer hitting API multiple times with certain records like something called paginations or doing some batch API load
Yeah.
for your analytical purpose or for creating your data big data pipelines?
Yeah. Mostly, I used to depend on traditional ETL mechanism because that's how
Mm-hmm.
it supports big volumes.
Mm-hmm.
Obviously, when it comes to APIs, if you do the batch way of pulling in a large
Mm-hmm.
volume, obviously it will
Mm-hmm.
hit roadblocks because
Mm-hmm.
the underlying systems, the APIs might not be designed to
Mm-hmm.
handle all that, right?
Mm-hmm.
So I
Okay.
would prefer basically small loads using the API
Mm-hmm.
methodology. But if it is
Mm-hmm.
really you want bulk volumes, it's
Mm-hmm.
ideal to choose some other ETL mechanism
Mm-hmm.
which can handle the big volumes, right? So, for example,
So even
say,
if you will use the ATL any ATL mechanisms, let's talk about extract part itself. I mean, again, sticking to the questions. Let's suppose you have to load a large data or big data from Salesforce, and even if you use the ETL in the extract part somewhere inside the code, even if you use some software. So I just
yeah,
wanted to understand the thinking methodology. Like even if you connect through some softwares or through some tools or you have your ETL pipelines or in ETL also there will be something called extract, right? Somebody has to write some code which will connect to the API.
yeah,
Now let's suppose I've given you two ways of connecting to API. One is that you are having you can hit the API, and you can get the records, certain number of records, like 200 records, and it will the paginated will be implemented, and it will show you the next API link, and again you can use that API with some authentication or authorizations, and again you will get the 200 records, and with 200 records will keep on coming. That's the one way. Another way is that you will hit one API, and it will just show that your it is in progress. And once after 2 minutes, you will again hit the API. It will say that it is completed, and it will give you the link, and it will use that particular API to get the data in either CSV file format or 𝗏𝗏 or whatever file format. So there are two ways. Like either you can divide your records into multiple chunks, get 200 records and put it into your systems, or you can also do the batch load, like get the CSV file or get the any other file systems and load it into your system. So which you will prefer from your architect point of view? If you have to load big amount of data, which is more preferable?
So obviously, when you talk about big, now you can look at the capabilities of the maximum limits on the API. So I would definitely go with the pagination method. In the traditional world, we call it time-based CDC. Some mechanism to break up the data, right? So the pagination would be an ideal method here.
Yeah, pagination will be, but don't you think that it will also involve some problem? Like, let's suppose you are hitting your API continuously, you are having millions of records. Let's suppose pagination supports 200 records per time. So millions divided by 200, it means you are going to call X number of times. The API call will be X number of times. Will that not create any problem on the server side? Their server can go down, right?
Yeah.
So how do you will handle this?
Yeah. No, definitely. I'm not really that. I don't have that really experience handling the pagination part, but I work on the typical ETL side where we have the same problems, right?
Right. So, please go ahead.
So obviously, now I look at what is the initial chunk or the packet size which I can bring. If there are handling too many packages, that will definitely have the overhead on the systems, on the extraction system as well as on the source. It's a case-to-case basis. I have to take a choice. What is the package size? It's possible limits on the system versus if there is a full batch extract if I can do.
Cool. And we can implement something like rate limiting or something. Even if we implement the paginations, then we can have certain rate limiting or something like that. Okay, let's move to the another interesting point that you have talked, that you are using batch. Most of your systems are batch, and some of the systems are also streaming pipelines. So with respect to two different world or two interlinked world, what all challenges you have found with respect to streaming world? Like when you design your systems with respect to streaming, I can see that you have used Kinesis and you have also used Kafka. So what all problem you face when you start doing this type of streaming problem? Can you just explain your project which involved streaming and what are all problems that you have faced in that particular project?
Yeah. With my limited knowledge on the streaming, we used Kinesis for one of the use case. See, basically, in the streaming scenario, your data set is limited, right? So, unlike the batch world, you have the full context of the data. Any analysis you want to do, you have sufficient amount of data within that extract where you want to compare with the previous record or something. So, all that is pretty much available in the batch world.
Right.
But when it comes to the streaming, your context is lost and you have to be specifically looking at a small set of records. So that's the biggest problem because you don't have the context. Like, some of the systems like Kafka will enable some data retention, all that. Again, like I'm not an expert in that area, but
I just wanted to understand. I can understand that you have worked in certain different skills. Just wanted to understand from your thinking perspectives that, you rightly said that there is a problem when in the batch we already have the data. We don't have to maintain our states, but in streamings we don't have the streams. Even if we use something called Kafka, which can retain up to 3 days, 7 days, or something like that. but then also we will not be having the data. That creates a bigger problem. Okay, cool. So now let's move to the your ETL pipe things itself. So when you are writing your ETL pipeline, how do you design your test cases, and where your test cases are mostly focused on? So I assume
The ETL, right?
yes. So let's suppose it's any code base. It's any code base, and it's typical ETL type of jobs. You might be using Apache, Spark or PySpark or anything to do your ETL jobs, where you're extracting data from certain source, you're doing some transformations and load, right? So which all test cases do you really care about when you are dealing with a normal pipeline? Let me just give you a simple example. Let's suppose your source is Postgres or Oracle, simple traditional database systems. Now you have used a Spark, or you call it any computing engine, and you have used a Spark to connect to that particular systems. Now the extract is done. Then you are having some transformation logic. You have written the transformations and then load it to the systems. How do you make sure that your pipelines are actually idempotent? And how do you make sure that your pipelines are actually resulting the expected result? How do you design your test cases?
Yeah. So the first thing, the first and foremost, right? The basic thing, whether it's doing the right job, what you need, right? So think about, whether you got all the data, right? Simple, record count, for example. Then maybe a high-level summary comparison between the source and the target. You can group by at a particular field at a particular level and then try to compare. And then other things obviously is your performance. What is your load time and the memory consumption? And then whatever the transformation logic you are building, whether all those transformation logics are actually captured, right?
Okay. And how do you run that? Let's suppose your pipeline is running every 4 hour, every 24 hour, right? How do you run all those test cases that you have just defined, right? Like you are concerned about, you are worried about count, you are worried about group by, you are worried about certain result. So do you place any external testing mechanisms, or your pipeline will actually, you will place your unit test in your pipeline itself, it will run? How do you make sure that your pipeline is working perfectly fine? Is there external systems that you can play?
Yeah. So most of the pipelining, what I have worked is through the ETL tools. So they basically embed all the logic for me. Like, they have a monitoring log, which gives me the record count, then all that, a detailed log. So traditionally, I used to depend on that. On the actual coding, if you ask me, without using an ETL tool, maybe I think that's a better way to embed all these logic directly within your ETL pipeline and then enable logging. So that way you can see. I'm just trying to see what an Informatica guys would have done, right? So let's say, I build the ETL pipeline using Informatica. When I run that job, it gives me a clear monitoring screen. Hey, how many records are extracted? What is the record count? All that. So if I was to do build this ETL pipeline without depending on Informatica or other tools, then I think it makes sense to put all that logic directly within your pipeline and build some logging mechanism. So that way you can monitor your logs.
Cool. Okay. So cool. And let's move to the next sets of problems. So let's suppose you are creating your pipelines. So, and currently you are loading data from some source, right? So how do you make sure that, let's suppose today you run your pipeline, and tomorrow you are going to run your pipeline, and you are connected through some database or some file-based system or some API. How do you make sure that you are actually not getting the data that you have actually processed, or you actually just load the data, or whatever data that is coming to you? How do you make sure that you are actually not reprocessing the data which you have already processed?
Yeah. So typically, I used to depend on timestamps. So that way, you maintain a mechanism to track what timestamps you have already extracted, and updating that log. That you can talk about like a temporary table or a log or something to always extract what was your previous extract, and use that as a mechanism to pull the data. But also, I used to think of it this way, for safety limits, right? I also depend on the safety limits, meaning pulling 1 day of data additionally. So that way, sometimes if you miss any data, you will get that data one more time. So obviously, it brings duplicates. But again, you need to handle those duplicates in the target
Yeah,
side.
right.
Duplication
It all
logic.
depends upon the applications. Like we can have exactly ones, we can have at most ones, or we can have
Yeah.
just ones. Yeah, it depends upon the scenario. Cool.
Yeah.
Let's. This is done with respect to the extraction part. Let's move to the loader part. So let's suppose, how do you maintain your data lake? Means whenever you are writing your data to certain places, how do you make sure that you actually maintaining your historical data, and you are actually also offsetting your data? What does offset means? Like, suppose somebody has made some changes in certain records, then it should be also updated in your data lake or whichever place you are loading your data. And
Yeah.
if some new data is coming, then it should be also loaded to that particular data lake. So how do you tackle this type of scenario?
Yeah. Basically, you want the latest record as well as you want to maintain the history, right?
Right. Latest record with respect to new data, and
Yeah.
latest record with respect to also some changes made in the older record also. I just want to update that too. Like update
Yeah.
and the new created. Yes.
Yeah. You can always depend on some kind of a time dependency scenario. Think of it this way: you can put a from date and to date. I'll take a simple example of
Okay.
employee master data, right? Today, let's say I'm a analyst for the last 3 years, and tomorrow I got updated to a senior analyst. So one way you can do is you can enable date from and date to, and then update the record. Whenever you see a change in a particular field column, for example, in this case the designation, right? You can update your valid from date, or to date will be anytime in the past. So that way you can get all the history for that employee. Now, if you want to get the latest record, you can always look by the current date, right? If you give any date, you want to get what is the employee position as of today, then you can just pass a SQL query between, right? So that is one way of doing things. Otherwise, maintaining two separate tables could be another option, right? One could be maintaining. Again, I will design based on the scenario. For example, what we used to do in the typical data warehouse world, the master data would be always, think of it this way. You have a sales transaction and then you have a product master data. The product master data is always updated with the latest records. So it's like a insert. You don't have the history there. But I also have a sales transaction table. Now, if there is some product attribute which you want to maintain through the history when that sales transaction happened, I can persist that attribute within the sales table. So that way, now at some time in the past, what was my product attribute? Now, when the sales transaction happened, I have a record there. So that is another method we used to do. But again, there is a disadvantage of that method. If for any reason you have to truncate all the data and reload, gone, right? You don't have the history.
Right. Okay, cool. So let's talk about one more common scenario. So with your experience, so let's suppose I'm having data in MongoDB, okay, or data in, let's suppose it's in the Postgres itself, and I'm having hundreds of columns. I created one big data pipelines, and there's two data pipeline I'm just assuming. I created one big data pipeline, taking all the data and put it into our data warehouse or data lake using some computations like 𝗲𝗡, Spark, Snowflake, and any other things. And we are loaded into some BigQuery or something like that. And somebody has created one pipeline, okay? And in that pipeline, they have defined their own aggregations. They have defined their own, selected some sets of column, like 10 column, and then loaded into BigQuery. So these are two different types of designing pipeline, right? One will have all other data, and that will give flexibility to the BI developers to light their own business logic using BigQuery or something like that, right? And in the second pipeline, it will reduce the cost because we will only have the selected number of columns. But whenever new requirement will come, then we have to again deploy another pipeline, or we have to do certain code changes there. So which one is more flexible when it comes to creating pipeline? Will you opt for the first one, like take all the data and put it into a data lake, or take some few of the data and create some model and then put it in data lake? And whenever the new requirements comes, then you again do the something. How do you decide?
No, that I got it. So basically, that comes back to the concept of data modeling. Like, if you are aware of the 𝗶𝗶 data modeling or the in-one type of data modeling, they have clearly set guidelines. They thought about all these problems well through, right? My approach is this way. In SAP, we call this as a layered scalable architecture, LSA. So what we typically do is you bring all the raw data into the first layer. Now, nowadays, think of it this way. The storage is very cheap. We all know.
Right.
So what I typically do is put the raw data into the first layer.
Cool.
So think of it like, more of a replication of the source tables as is without any business logic. Okay. And then that is my base layer, or and then I have the next layer that is called an integration layer. Again, what I'm trying to do in the integration layer is denormalizing the data, because again, like too much of normalization is not good in terms of query performance, overall cost, all that, right? So typically the integration layer is denormalizing this data. Think of it this way, like for example, just for my sales, right? I have the sales header information in one table, item data in another table, delivery, shipment, all that, right? So I'm trying to build a reusable model in the integration layer. Again, no specific business logic. We are, you got up a good point. Like you're talking about the reusability, right? And at the same time, agility, like how fast you develop and the performance, right? In the real world scenarios, you also deal with multiple businesses. Like for example, there could be, for example, there is a business. Any company has multiple products, right? There are multiple business functions. Don't try to put in any business logic, which is specific to that business into the integration layer. So that way it can be reusable, right?
Perfect.
So that is my integration layer. And then on top of that, I go with the data mart layer. There you play it around, right? So you want to embed your particular business logic, or you want to aggregate the data. All that you play it around that layer. So tomorrow, if you want to add some other new logic, like a new column or something, you don't need to go back to your source, because you have the first layer raw. And at the max, you want to go to integration layer or go back to the base layer. Right? I dealt with the tables which has thousands of fields. I don't need it on day one to use all the 1,000 fields.
Right.
But at the same time, I don't want to go back to my source
Mm-hmm.
and every time when I want a new field.
Right, right,
So that's
absolutely.
the approach I would follow.
Yeah, yeah, I really, really liked it, and your experience talked about it in very clear way. So I actually try to ask this particular questions to most of our candidate, and they don't realize that it's actually system design questions. I'm just asking these questions in a very layman terms, and they don't realize that we can actually divide the zones into multiple parts. Like you talked about raw, you talked about integration layer, then you talked about data mart, and each zone has their own capability to of doing that, and that gives us agility, and that also gives us way to load the source data in a much quicker way as a data teams. Rightly said. I really impressed with this particular answer. Ganesh, I'm mostly done with my interview. I think we have made it long, but yeah, thank you for your time, and good luck for your future. Thank
Yeah,
you very much.
thank you. It was nice talking to you, Ankur.
Yeah, thank you, Ganesh.
Bye.
Bye.